All right, so Arithmetic Series. So now what the key word is, what we're talking about today is series. Okay? Series, you need to know what that means. That means the sequence added up. Okay? So you have a sequence, which is the pattern. The series is that pattern added up to a given term. So they say they want the series of term 8. That means they want term 8, term 7, term 6, term 5, etc. added up. Okay? So right here, they give you an example. So this is what it tells you. Arithmetic series is a sequence added. Okay, it gives you a little quick example here. Here's a sequence, 3, 5, 7, 9, 11. They want the series of that sequence, so they add that up. You get 8, 15, 24, you get 35. So the way you write that is series 5, big S, 5, is 35. Okay, and another way you can translate that is, I kind of think of that S personally as a sum, adding them up. So I think sum of the 5th term. That's the way I think of it. Okay, but you can think of it series as well. I don't know the exact which one it actually represents, but okay, so that's just the basics of what series is, and we'll go ahead and get into how it came about. So, oddly enough, I did a report on Carl Gauss in college, for those of you who were wondering. Okay, famous mathematician, but anyways, he just summarized the story here. His teacher, back in the old days, used to give them arithmetic work and just busy work to keep them busy practicing, because that's what math's about, is practicing. And one day he said, I want you guys to add up numbers 1 to 100. I want you to add them all up together. So everybody in his class is writing them all down, adding them all up, doing 1 plus 2, 3, plus 3, 6, and just keep doing that. He got his done in about 2 or 3 minutes. Brought the answer to the professor because he figured out a pattern, because adding all the numbers up from 1 to 100 is adding a series. Okay, this is what he did. He figured out that if I did 2 of this series, what's 1 plus 100? What's 2 plus 99? It's 101 for all of them. Does that make sense? And so what he did was, he did 2 series of 100. So he did 101s all the way to 100, which essentially is 100 times 101. So that's 2 of them. Does that make sense? Yeah, so 2 times series of 100 is 100 over 101. So if we times this first, you're going to get 10,100. So that means 2 series. If you add up 100 twice, you'd get that. So we're going to divide it by 2. And then he got his answer, so he put on the teacher's desk of 50, 50. So if you add up numbers 1 to 100, that total is 50, 50. 5,050. Okay? So the formula, because you're going to get formulas, you don't have to memorize them, is based off of that logic. We're going to times our series by 2. We're going to put our series, which remember, we're still going to use our same, this is still going to be involved. That's still going to be involved. Okay? We're going to times that by 2 and then divide it by 2 at the end. So you'll see what I mean here in a second. But so just kind of a short story there, what that's all about. Okay, so here, this is talking about how we put together the formulas. Let's skim through this real quick. All right, so again, like I said, don't forget that this is always going to be used. Okay, a plus n minus 1. So now here's kind of where the pattern's created. So if I did a series, my first would be a plus d. My second would be a plus 2d, a plus n minus 3d. It just would keep going for the whole pattern. Those are just, I know they're variables, but again, think about it as the pattern. You have your first term, plus your difference. Your second term, or excuse me, your first term plus 2 differences just keeps going. Okay. Then I'll just kind of briefly talk about this without confusing you too much. But what they're doing here is that if you do what Gauss did and you add the 2 lines together, okay, it'll form this right here. Okay, this right here is what's on top. So then where does the 2 come from? From dividing by 2. So you can kind of see his logic creates this formula. So this right here is used when you have 3 of the 4 pieces of information. And please focus on what I'm saying here, because we're going to have another formula that's used for a different spot. 4 pieces of information. What do I mean? I have N, A, D, and S sub N. Those are my 4 pieces of information. If you have 3 of the 4, use this formula. Okay? If you have on the bottom here, I'll show you the other formula. Any questions on that yet? We're going to do some examples. It'll kind of make more sense, I think, with the examples. Okay? All right. So, this one we want to use when we do not have a common difference. Whoops. No D. We don't. Nope, they're on your formula sheet. Yep, these are on your formula sheet. Okay, so this one's used when you don't have a common difference. That's why there's no D on here. This one is when you have 3 of the 4. Okay, people ask class, we're not sure, what does it mean by T sub N? Well, if I made this up here, let's just make up an easy one here. 2, 4, 6, 8, 10, 12. That's T1, 2, 3, 4, 5. This is T6. Right? So if I want to find the series S6, we're pretending we don't know the common difference. I know you do. Okay? S6, well, what's my N then? 6, right? My A is still 2. My T sub N, that is, what is your 6th term? It's 12. All over 2. 2 plus 12 is 14. 14 times 6 is 84. Divided by 2 is 42. So S6 kicks out 42. Well, let's just check it. 2 plus 4 is 6. 6 plus 6 is 12. 20, 30, 42. So just proving that it worked. Okay, let's go ahead and roll off a few examples here. We've got 4 examples, another little investigation, and then one last example. Okay, so this one here. Determine the sum of the first 14 terms of the arithmetic sequence in the series. So remember, there's always 4 pieces of information. So in this case, S of 14 is my unknown. We don't know what that is. That's our job to find that. But with that, we do have an A, 9. We do have a D, 6. And we do have a N, 14. So in this case, I have 3 of the 4 pieces of information. So I'm going to want to use that first formula. Okay, so this is what it'll look like. S of 14 equals 14 times 2 times 9 plus 14 minus 1, 13 times 6 all over 2. Okay, so I've plugged everything in. Is there any questions about it? I got the 13, I said the N minus 1. I did 14 minus 1. Okay, important thing, you can mess up your calculator. Make sure you understand or realize that these parentheses keep all this together, so the whole thing's times by 14, not just the left side. So I like to do the parentheses first, and I also like to do 14 divided by 2 to get rid of the fraction, because the 14 can divide by the 2. So I can write it like this. S14 is 7 times 18 plus 84? No, 78. So then S14 equals 7 times 96. So S14, 672. That's the basis of finding a series. Okay, so this one here wants the sum of the 22 terms. So we want S22. We don't know that. We know what A is. We know what N is. We do not know what D is. So we want to use the second formula. So the second formula says we want S of 22 equals N, which is 22, times A plus T sub N, which T sub N is 45, all over 2. Again, I like to do the fraction first. 22 divided by 2 is 11. 11, negative 18 plus 40 is 35, 27. Should get 297. Questions yet? Okay. All right, we got 3 and 4 here. All right, we'll do 3 first. All right, so 3. Find the sum of the terms of sequence 17, 12, 7, negative 38. What's the issue here that we haven't had yet? What's wrong? Well, yeah, we're decreasing, but do we know what term negative 38 is? That's the issue. So you still have to go back to stuff I've already taught you, and we have to figure out what this is. So we know it's negative 38, right? That's my T sub N. I don't know my N, but what's my A? 17 plus N minus 1. What's my D? Negative 5. See that? By plugging all that stuff in that we know, we can see we can isolate N and figure out what term number that is now. So I'm going to minus 17 over. That gives me negative 55 equals N, negative 5N, excuse me, plus 5 minus another 5 over. This is the 12th term. We expect N to always be what? Positive, right? We're not going to have a negative term number. Okay, so always expect your term number to be positive. Okay, so now we have A, N, and D. We can use our first formula. Okay, so going back to that, we want S of 12 equals 12 times 2 times 17 minus 11 times negative 38. Oh, no, not negative 38, excuse me. Negative 5. Okay, all over 2. Again, 12 over 2 is 6. So S12, that gives me 6. 34 minus, let's see here, minus negative 55. Make sure I got this going right here. Oh, no, it's plus. So 34 plus a negative 55 gives me a negative 21. So 6 times negative 21 gives me negative 126. Now your sums can be negative because you're adding negative numbers together. Okay, and if you look, 17 is far left, negative 38 is far right, so the right side's heavier than the left side in terms of negatives, if that makes any sense. Okay. All right, 4. Move this up here. All right, so Peter starts work at a salary of $16,000 per annum. He receives an increases of 850. He works at a firm for 12 years. So it wants us to calculate T12. So this one, understand the difference. This wants T12. This one wants what? How much money he makes in 12 years, so that would be S12. That's the difference in those questions. This one wants to know how much he made on the 12th year. This one wants to know how much he makes in 12 years. Okay, so calculate his salary in the 12th year. So let's figure out our A's and stuff. Our A is, see here, our A is still going to be 16,000, because that's how much he starts with. D is the 850. Okay, and then we know N is 12. So to figure this one out, we want to use just our regular formula. We want to use 16,000 plus N minus 1, which is 11, times 850. That will kick out our T12 answer. Our T12 answer is 25,350. Okay. For our series, we're going to use our first formula, since we have 3 of the 4. So we're going to go 12 times 2 times 16,000 plus 11 times 850 all over 2. So 12 divided by 2 is 6. 32,000. See here, 32,000 plus 850 plus another 850 or 8,500. What's this one? What's 850 times? 9,000, that's right. Okay, and when you put that in your calculator right there, it kicks out for his whole 12 years working there, he'll make $248,100. $248,100. Okay, so our last piece here, and try to stay with me, I know we're going long here, but the last piece is another way of figuring out a term number. I'm going to kind of explain to you what it's doing first, because last class I got confused, so I just went right into it. What they're doing is they're saying that if I took my series, let's say I took S8, and I took my series 8, and I subtracted the same series, a series 7, what would I be left with? If you did close. Not series 1, but if I did, so watch. Let's just make one up here. Let's go 2, 5, 8, 11, 14, 17. So I have 6 there. Okay? If I took series 6 and I minused series 5, what would be left? I'd be left with this, which is term 6. So series 6 minus series 5 gives you term 6. So it's a way to find your term numbers if you need to. It's like cutting off a piece. So that's what this is going to be about, okay? So just kind of stay with me. I'm going to go through it, but it's a lot of, I don't want to say verbiage because they're not words, but it's a lot of letters. Okay, so they tell us that our S of n is 2n squared minus n. So then they plug in 1, okay, and they get 1. So my T of 1 is always S of 1. Your term 1 is always series 1. That's always the case, right? If you have one term, your series is that one number. Okay, so that's what this is talking about. Okay, now go to the second one, though. Change it a little bit. So put a 2 in. You get 2 squared is 4. 4 times 2 is 8. Minus 2 is 6. Okay, S2 is equal to S1 plus T2. T2 is equal to S2 minus S1. T2 is 6 minus 1, so T2 is 5. And then we're just going to kind of fill out the pattern that they want you to do here. So now here, it was S1 plus T2. Well, this time I want S2 plus T3. And T3 is S3 minus S2, which we can do. Okay, S3 is 15 minus 6. So T3 is 9. Okay, S4, 2 times 4 squared minus 3, or minus 4, excuse me. Okay, that's going to give me 28. S4 is S3 plus T4. T4 is S4 minus S3. 28 minus 15 is 13. Okay, so it's just sharing with you the pattern. So express T10 in terms of S. So T10 in terms of S would be series 10 minus series 9. That's the whole point of this. It's understanding that you can get it by that series subtracted by the series before it. Then it says express it in terms of n. So in general, T sub n is equal to S sub n minus S sub n minus 1. The number before it. Okay. Everybody have that? Okay, so this yields the formula here at the bottom. We're going to do one more thing here, just putting into simplified terms, but this yields this formula. T sub n is the same as series n minus the series before it. And notice that it has to be greater than 2. You can't subtract 1 minus, you can't do series 0. All right, so for part D, what you want to do in part D is it says, once you have A is 1, if A is 1, then D is 5 minus 1, which equals 4. And so it wants you to use that to plug it in. So T sub n equals 1 plus n minus 1 times 4. When you simplify that, you get T sub n is 4n minus 3. And what we're going to do is we're going to do the other side using the series. This is the way we're used to, right? That's our normal formula. We're going to use the series formula, and we're going to show that it cancels out. So we're going to take S of n, because we know that T sub n equals S of n minus S of n minus 1. So what we're going to do is, here's S of n, right there. So I'm going to go T sub n equals, using this, 2n squared minus n minus 2n minus 1 squared minus n minus 1. So wherever the n's were, I put an n minus 1's all I did there. Okay, to save us some time, you're going to FOIL this stuff out here on the right. And when you get down to that point where you're combining like terms, you should have something like this. Something like this. And so then you'll see a few things cancel. This goes away. This goes away. And you're left with 4n minus 3, which you can see is the same there. So just proving to you that our term formula works with this as well. Okay, and that was just the investigation for that. Got one example, and we're done. All right, so when do we want to use that? Well, for a problem like this. For a certain arithmetic series, S of n, you're given the pattern is 1/2 n, 11 minus n. Determine the first 4 terms of the corresponding arithmetic sequence. So we don't want to figure out the first 4 series. If you're like, well, we'll just plug a 1, 2, 3, and 4 in. We don't want to do that because that gives me the series, right? This is the series formula. So, but remember, your S1 equals your T1, right? So we can plug in a 1, that'll figure out our first term. So our first one I'm going to plug in a 1 in. 1/2 times 1 times 11 minus 1. So that gets me 1/2 of 10, right? So my first one, T1 equals 5, S1 equals 5. Okay. What's that? For S2? Not for T2, for S2. Now S2, we can do this, right? It's going to go S2 minus S1 equals T2. So I already know what S1 is, 5. I need to figure out what S2 is by plugging the 2 in. Okay, so plug a 2 in. 2 times a half is 1. 11 minus 2 is 9. So I got, for S2, I got 9. So then I just go right here. I go 9 minus 5 equals 4. T2 equals 4. Right? So now, for T3, S3 minus S2. We already have S2. I just got to figure out S3 real quick. So I plug in a 3. So it's going to be 3 halves. 11 minus 3, 8. 8 times 3 halves, that's going to be 12. So S3 is 12. 12 minus 9, 3. Term 3 is 3. And you can see it's going down by 1 every time. Okay, wants to find T4 is the last one here. T4, S4 minus S3. Okay, so we have our S4 is 1 half of 4 is 2, 7. S4 is 14. 14 minus 12 is 2. And that's it. Okay. So again, this is just basing off of the investigation we just did, that S of n minus S of n minus 1 equals term n. And we just use that to complete our pattern there. All right, that is all. Your problems are on your homework sheet.